All right, gang, we're going to do the discontinuity on this function. So remember, when the angle is sped up, which is in this case the 2x, the 2 times the x, or slowed down, you always take care of that last. All right? So we know that this is one of the functions that has an infinite amount of asymptotes, right? We know this is like one of those functions where it's one parabola up, one parabola down, one parabola up, right? It looks like this, right? And it's got an infinite amount of asymptotes. So because it has an infinite amount of asymptotes, we're going to write an expression, an equation that will generate the infinite amount of asymptotes. All right, so to do that, you first want to figure out where the basic cosecant, not the 2x, the basic cosecant is undefined. Okay, and that means that you're looking for, it's 1 over sine, so you're looking for where the sine is equal to 0. So the sine will be equal to 0 at all the whole pi's, all the whole pi's. So for instance, it would start at 0, and then I would add pi to get to the next one, and then I would add pi to get to the next one and add pi. So by adding pi n, where n is 0, 1, 2, 3, and all negative integers as well, right, where n is an integer, right, this means that all the rotations in a positive direction or negative direction. So this is where we then put the 2 in, because it's not x, it's actually 2x. All right, so it would be 2x equals 2, and because it's plus 0, we can ignore the 0. Right, we don't need to worry about the 0. So 0 plus pi n is pi n, and then we can just divide off the 2 at the last part. So the VAs are going to occur at pi n over 2. So that means, just to write the answer out nice, the discontinuities will occur when x equals to pi n over 2. They're non-removable because they're vertical asymptotes. And where n is an integer. Okay, so that's the answer to this one. It's going to happen at pi n over 2, which is not non-removable because they're VAs, and in this equation, n is an integer. All right, now let's try the other one. Let's try 59. Now when it has these double brackets, remember that's the step function. And this step function is shifted to the right 8 units. So if you remember this function from pre-calc, this is just going to be the stair function, right? The step, it's also called the greatest integer function. It's just a bunch of stairs. All right, and it's shifted 8 to the right, but it's still going to just jump. It's still going to just jump at every integer. So for this one, you want to say that you have a discontinuity at every integer. You have a discontinuity at every integer, and because these are gaps, you're going to say that this is non-removable. Remember, vertical asymptotes and gaps are non-removable, and holes are removable. Okay, gang, I'll catch you. Bye-bye.